Okay, for the solutions for the functions and linear models mock exam. A plumber in Australia charges 90 Australian dollars per hour for work plus a fixed cost. His total charge is represented by the cost function C equals 60 plus 90t, where t is in hours. Write down the fixed cost. Okay, the fixed cost they just said is the plus on top of the 90 times time, so it's just the 60, right? So we put 60 here. And then it's also the y-intercept. It corresponds to the initial fee for the bowling problem that we did in the investigation. So it's just, you can think of it a variety of different ways, right? B, it takes 3.5 hours to complete a job for Paula. Find the total cost. So we write down the equation again, except this time we're going to put in for t, we're going to put 3.5 hours. So we put 3.5 here. We can do the multiplication on the calculator, or you can do it in your head, and you get $375. Okay? So, and the other way you could do this is you could program it in the calculator. You could put y equals, and we're going to put the equation in the calculator. Since we have the equation, why not? Many answers just pop out of the calculator without us trying. So we put 60 plus 90t. And then we're going to graph it. Okay? And then once we graph it, we are looking for the, and looks like we need to maybe do zoom fit because it's not coming out. Okay? That's unfortunate. Oh, there we go. So we'll do zoom. Actually, let's fix the window size because the window size looks very huge. Okay? So instead of X max 400, we're going to put 10. And then we're going to do zoom. Zoom fit. Always start with zoom fit. And then we're going to graph. Okay, that's better. And then there's a couple ways we could find the 375 here, but you know, one way to do it is we could do a trace and type in 3.5. So we could do, we'll say, what is the value of the y when the x is 3.5? So we do trace 3.5, enter. And then it'll go right to the point, and hey, the y value is 375. Okay, the other way to do it, it would be second table. If you do second table, we'll just scroll down to, oh my god, look where I'm at. Okay. This is awful. Let's see, I want to get back to 0 and quick, right? So let's see, I'm going to change the plus value to 10, the increment to 10, and then it's going to jump by 10. So it's going to be a lot faster to go back to 0 here. So I'm going to go back to 0, and then I'm going to check what the value is at 3.5. Oh my god. Sure is slow, isn't it? Oh, here we are. We're getting close. Okay, and the problem here is, hey, there is no 3.5, but you know, I could use the plus value and I could change the jumps to 3.5, and then magically there's 3.5. Okay? And there's the y value of 375. Then I want to go back to my initial value of plus 1 so that my table is nice and neat. Okay? But so those are two different ways that we could have found the value is 375 besides the algebra. I wouldn't even call that algebra, it's just substituting in, right? Steve received a bill for 510 Australian US dollars. Calculate the time it took for the plumber to complete the job. Okay, now we could, let's do it with the calculator first. So we got the graph of the function. We want to know when this graph reaches 510, okay? And that's maybe kind of hard to do because we can't use trace anymore, right? So let's try table. Okay, and let's see, when is 510? Oh, there it is. Do you see? The y value is 510. The x value is 5. Okay? Wait a second. How come I got a different answer here? 510 equals 60 plus 90t. Let me check my equation here. 60 plus 90t, that's fine. Okay, so it's not looking good for my algebra here. What did I do? 510 equals 60 plus 90t. 510 minus 60. Oh, I didn't subtract here. This should have been 450, right? 510 minus 60 is 450. So 450 equals 90t. This should be a 5, right? Okay? So I could use algebra like I did here, except I did it wrong. Or you're going to use the table, for example, and then you could find it. using that. Okay, 510 here, 5 here. That's a good thing about math studies problems is usually they're integers, so we can use the table and it will work just as well. Okay, now you can also use intersection. The way you would use intersection to do this is you would intersect this line with the function y equals 510. So I'm going to go here, and then I'm going to go down, and then I'm going to put in the function y equals 510. 510. Okay, and then I'm going to graph them both. And then they're going to intersect. Where this line intersects y equals 510 is this intersection point. But we want to know what is this intersection point. We can find the intersection point by doing second calc, and then we do intersect, and then we say first curve, yes, second curve, yes, and then guess. It doesn't really matter because there's only one intersection point. Hey, there it is, 5, 510. 5, 510. Is that right? Yes. So they want to know x equals 5, so then you put 5 here. Okay? All right, moving on. Number 2. They have this line here, and they give us an equation, x plus 2y equals 12. If you have an equation, what you're going to immediately do is put it in the calculator. Unfortunately, this equation does not have y equals on the left side, so you are going to have to do a little bit of algebra here. Take the equation x plus 2y equals 12, and you are going to solve for y so that you can put it in the calculator. So you put x plus 2y equals 12, 2y equals 12 minus x, and 2y equals negative x plus 12. You just rearrange these two. And then you divide everything by 2. Y equals negative 1/2 x plus 6. Okay? So looking at this, you can already see from what we know about gradient intercept form that the point P, which they're asking for, the coordinates to point P, are going to be 0, 6. The y-intercept is 6. So we would put the point P as P, 0, 6. And then the point Q is a little bit harder. Okay? Now let's take advantage of the fact that we put this in our calculator. We put negative 0.5 plus 6. And then we're going to graph it. Graph. Clear. Okay, then we're going to graph this. Oh, I forgot to put, did you see what I did? I forgot to put the x. Or maybe I pressed the x and it didn't come out. Okay. Okay, so now I have the equation in there. I graph it. Now I have the proper equation in there. Taking a really long time to graph. Oh, I know. I think a graph, but we just can't see it because the zoom fit is so far off. Remember, our zoom fit is like really tall right now. So we're going to change our zoom fit so it's not so tall. Okay. All right, that's better. Okay, so now it looks more like this, right? Okay, and then so now we want to know, okay, what is this point here? We already know that 0, 6, but let's say we didn't know. We could do a trace. And it would be 0, 6, right? And then we could do a trace and go down here. Oh, let's go all the way down to the x-axis and see what it is. 5, getting closer. 10, 1. We want to go to y equals 0. Looks like it's going to be about 12, doesn't it? And we can find out for sure by doing a second table and going down to the, let's see, when is y equals 0? Because that's what we want to know. There it is, 12, 0. That's the other point. Okay? Moving on to the next part. It says a second line with equation x minus y equals 3 intersects the line that we were given. At point A, find the coordinates of point A. So if we can just put this line also in the calculator, then we'll be able to find the intersection very easily. So we'll take x minus 3 equals 3. We're going to rearrange it so that y is on the left with our algebra. Okay, so what you're going to do is you're going to add y to both sides. You get x. You're going to subtract 3 from both sides, and you'll get x minus 3 on one side, and you get y on the other side. Okay, so like for example, if you add y to both sides, then y is going to appear here. It's going to disappear here. Subtract 3 from both sides. This is going to disappear, and it's going to be x minus 3 on this side. So that's how you get y equals x minus 3. Okay, once you have y equals x minus 3, then you put your second equation, x minus 3, here. X minus 3. Okay? And then we're going to graph both. Okay, there's the other line. And then we just want to know where that point is. So we could do second, calc, and then we go down and find the intersection. First curve, yes. Second curve, yes. And then we're just going to say, yeah, that's our guess, whatever. And there's our intersection, 6 and 3. Okay?